So I know that it's working. Can you guys hear me okay?
Yes.
On Zoom. Okay. It's weird. Like basically what happens when I start this, it it automatically opens up YouTube, and like initially it was throwing me like all this weird feedback, but now I know the feedback is good, and that's what I was. So I was looking for that feedback to get a confirmation. Let me check. I think we're good as far as attendance because I think that whoever's going to be here essentially is here. Okay, so let's kind of do a quick recap for our announcement. So in case the other people are watching this, they can like get this a similar introduction. So I think I owed you guys a lecture from Monday, right? Section 4.5, which was the integration technique on substitution. And today we're supposed to do integration by parts, right? So what I did, I went on and created both of those lectures just before class. It's like the 3 or so hours before class. So I literally just finished it. You had to kind of do the best you can with those presentations because I was totally exhausted by the end of like the second presentation. So I was making hella mistakes, right? But I mean, we were able to. I was able to get to the bottom of all the mistakes and kind of clean it up as best I can. But I can understand if you're trying to learn, that would be a challenge. I probably should go back and redo them, but I probably won't. But with that, the idea is that okay, one, we are done with the new material, right? That was the last of the things that I wanted to cover for the semester. So with that, we're officially ready for exam 2, right? Exam 2 should become available on Monday, and it'll be due the following Monday. So it'll be available this upcoming Monday, and it's going to cover chapters 3 and chapter 4, right? So today I want to take as much time as we can to get through as many homework questions regarding sections 4, 5, and 4, 6 as I can. And then I do acknowledge that I know I have some recordings that if you go to the playlist, you might not see them. They're on my channel. I just need to put them in the playlist and organize it, right? So the recordings are there. I just need to organize them the way I did everything else so you guys can find them, right? And then another thing, I know a student just asked about how do you see the grade? And so what I wanted to do, I wanted to pull up our syllabus and see the grading rationale, right? So we already have that there. That's right here. So the grade is going to be 2 exams where each exam is 30% each. The homework and quizzes are going to be 15% of your grade total. So that means that your homework is what, 7.5%, and your quizzes are 7.5%. And then the final is 25% of your overall grade, right? So what this means with your grade, all I'm going to do to calculate your grade, I'm pulling this straight from Pearson. So whatever grade you see on Pearson, that's gonna be the structure or the backbone for how we calculate your grade. So all I'm gonna do is take your highest score in exam 1, I'm gonna say times 0.3, plus your highest score in exam 2 times 0.3, plus your homework average times 0.5, plus your quiz average times 0.075, and then plus whatever score you get on the final exam times 0.25, right? So the way you factor in those weights, you take the average times that percentage as a decimal, all right? So that's how I'm going to calculate your grades. Hopefully that made sense. So if you want to get a sense of where you are, if you go on Pearson, if you take your exam 1 score, you say times 0.3. You take your exam 2 score, say times 0.3. You take your overall homework average, you say times 0.075. You take your overall quiz average times 0.075. And so what that means is that without the final, the highest that you can earn is what, 75%, right? So then at that stage, what you do is you just play with different scores that you think you can obtain on the final, right? So say you got like a 50% on the final. Based on your current score, then that's what your overall grade should be, right? Say you got a 70. So you would say 70 times 0.25. That will give you a sense of your final score, right? So you just play with different scores that you think you can earn on the final exam. But that's essentially what I'm going to be doing. So it's a little bit hard to gauge your score right now because that final is not there. So then that's why you play with different scores that you need to make. Once you get the baseline for your grade, then you play with the different scores of the final to get a sense of, you know. where you are. If that doesn't make sense, just let me know and we can look at some examples or whatever. So, we can look at your scores outside of the stream.
Yeah, I think
Hopefully
that's
that you got it.
yeah, I
That was
think
okay?
yeah, I'll probably like later on the semester, close to the end, and just go through just to make sure I'm like, just doing decent enough.
So the main thing, if you're really just trying to do well in the class, if you don't do anything else, just make sure that your exams are in order. Your exams, what, 60 plus 85% of your overall grade.
Yeah.
The homework and quizzes were really just there to kind of get you ready for the exams. That's why it's a lot. The homework and quizzes are a lot of work for a little bit of points. So you only have 2 exams and a final, and you got a lot of wiggle room. You just need to take advantage of the wiggle room, right?
Yeah.
We get unlimited attempts on these assignments, and there's only a 10% late penalty. Let me remind everyone listening that of the hard deadline of May 1st at 11:59 p.m. That's a Sunday night going into a Monday morning. Once we hit 11:59, all this old stuff locks out. You won't be able to access it anymore. And then from that point until like Friday evening, sometime Friday evening, for that time span, you're gonna have access to your final. So once the final is available, you won't have access to anything else. So that's why you want to take time now. Again, if you don't do anything else, just make sure your exams are in order. Get them as high as you can get them with the stipulations, and then that should position you for success. All right.
I appreciate you. Thank you.
Yeah, that's good. Okay. So let's see. So with that, let's take some time. So again, I went on and did the lectures for 4.5 and 4.6. I do admit they were rather choppy, especially towards the end because I was just exhausted and there's a lot going on. It was raining and storming. My dog kept doing stuff that made me want to throw up. So she kept licking herself. I was like, "Will you please? I'm trying to focus." Like it was so gross, but it was funny. So I was just totally distracted. So what we're going to do now, let's take some time and go through as much of the homework questions as we can. And again, we can kind of jump to other things. What's today? Today is Wednesday. And now also, so next week, when exam 2 is available, more than likely, I'm just going to be available for questions during that time, right? So you can ask me questions about the current exam. Anything that's on Pearson, you can ask me questions about it, right? We can talk about it and try to get to the bottom of it. It is a good idea to kind of have your questions ready to go. And if you don't have questions, that's fine too. I'll just do the best I can to be available and we'll kind of go from there. So let's get past this augmented review. We want to get into section 4.5. So I'm going to just kind of fast forward until I see 4.5. First question for section 4.5. So we're asked to evaluate. So this technique, so we can use this as an introduction to integration using the integration technique of substitution, right? And be sure to check by differentiating. So sometimes these can get a little bit funky. We're going to do the best we can. Let's go ahead and get a copy of this guy. Type an exact answer using parentheses to clearly denote the argument of each function. Okay. So, best we can. Again, sometimes these can be a little bit dicey. So let's just give it a go. Here. This is question what? This is question number 8. This is the first question that comes from section 4.5, question number 2 from the back of the section, right? Okay, so substitution. So the way substitution goes, we're gonna trying to integrate this directly. Obviously, you're not gonna be able to do it, right? You're not supposed to. So we're gonna try this technique with substitution. So let's see, for instance, let's let u be this 5 plus x to the power of 6, right? So then if that's our u, then our du, the derivative of that guy is going to be 6x to the power of 5 dx. Whole thing, was that partial fraction decomposition? Or what was that called? I still haven't remembered the name of that technique. Hang on. Integration. Yeah, partial sums. No. It's slipping my mind the name of this technique. U, and we have the derivative of u, right? So notice that 6x to the 5 dx is right here, right? So that's a good omen that we've chosen the proper u. Okay, so now let's do our substitution. So we're starting with 5 plus x to the 6 to the power of 8 dx, right? That's what we're starting with. Now, if we do our substitution, the 5 plus x to the 6, that's our u to the power of 8 du. Much easier to integrate, right? This substitution after the substitution. So then we get the integral of u to the power of 8 is going to be what? U to the power of 9 over 9 plus some constant. Integrated, now we just put the substitution back. So then this is going to be 5 plus x to the 6 to the power of 9 over 9. With something like this, you check by taking a derivative. The derivative of a constant, this term goes to 0. The 9 comes down, and they're going to cancel. Then we're going to be left with the power of 8. Then we got to see times the derivative of the inside function. So times is 6x to the 5th, right? So if you take the derivative of this guy, you get back to the original. So let's take this result and submit and see how do we do. Let's do C's. X to the power 6, 5. Can I use my keyboard? Let me see. Ooh. We got 5 plus. It's already spazzing. I don't know why it's doing that. It's like double clicking everything. It's so weird. 5 plus x to the power of 6. Okay. Let's get rid of this. B. So we got another substitution. So substitution technique, right? So the challenge with these is choosing the correct substitution. So let's see. So we're going to let u be 4t cubed plus 1, right? So then our du, the derivative of that is going to be what? 12t squared. Oh, 12t squared dt. So we have our t squared dt, but we have this extra 12 in there. So in order form to get that 12 there, we need to multiply by 1 in a certain form so that we get that where we want it to be, right? So let's start with a copy of the original. This integral four, no, that's not a four, plus one times t squared dt, right? We need a 12 next to that t squared. So we're going to multiply by 1 in the form of 1 times 12. Everything else is the same. Doesn't change our result. It just changes the form. It manipulates the form into something that we can use, right? It's the same as cube plus 1 now that it's in this form, this is going to be equal to 1 over 12 of u. That technique of multiplying by 1. Now we're able to transform the original integration or the original integral into this form that you see at the bottom of the screen. And so now this is much easier to integrate. This is going to be 1 over 12 times u squared over 2 plus some c. 4t cubed plus 1 plus. Then I feel like you should have questions, but I totally understand if, you know, I'm not gonna lie. No, it is, I just get it. Just do the best you can. Let's see how do we do with this guy. I'm trying to think what I need to do to get this to work. I don't know. Let me put it here. Cubed plus 1. It says determine a change of variables from t to u. We said let u be 4t cubed plus 1. So we got b there. Let's go with b. So u. We got u over 12 du. So it just needs to be u over 12. Our answer that we got. Now let me see if I can use my keyboard. If I can use my keyboard, that would be nice. Here, is that why I was behaving that way? No. If you're using a screen reader or navigate exclusively with a keyboard, you can enter answers only using command line language. I don't want that on. 4t cubed, so 4t to the power of 3. This worked. So if I use that, du is that, right? Fine. So it should be u squared over 2. Did we? I feel like we squared. I did, but wrote it, I forgot to put it. It's not working. I'll figure that out later. It's probably something has to be rebooted. Let's just try another one. And just stop me if anything isn't clear or if we need to go back. Let's see. X is not equal to 4, negative 4. Okay, let's try this one. Oof. So so let me see the time. This will probably be the last one for this section. Integration by parts. We're gonna try. We need to try some of them. So now you, let's see. In this 8 plus 2x, so that means our du would be what? 2 dx, right? So the derivative of that guy. And 2 dx is there, right? So then if we do our substitution, this is going to be the integral of over u. U over u, right? So then this one, the integral of du over u is natural log. So this is going to be the natural log of u plus some constant. Substitution back. So this should be the natural log of 8 plus 2x. Um, be what? 2 over that. Let me just put absolute value. That's the only other thing I could think is that there might need to be absolute value. comes because you got x is like negative, you know, a log of negative numbers, or let me see, you know, rules for when you know the central part is positive, so you have to force it to be positive. X is positive. Let's see. Uh, I kind of want to do this one. Let's do this one and then we'll move on to integration by parts. By parts. Let's see. So substitution here. All right. Start by we're gonna let u be the natural log of x. So then our du is going to be what? Dx by this looks okay so far. So then if we do our substitution, this is going to be u to the 30 du. The integral is going to be u to the power of 31 over 31 plus some c, and then you substitute back. So that should be the natural log of x to the power of 31. Of ln x to the power of 30. Because we're past the halfway mark. Um, let's go back and try to work a few questions from. And we'll go until we get to the one that's some questions for 4.6. 1, 3.5. Okay, so this is the integration by parts, right? So that's another technique. Okay, so let's get a copy, and I'll try to give you some context on that one, on that technique. When you're doing integration by parts, like you might try to do substitution and then you might find that it doesn't work. So then with integration by parts, we're going to pick a u and a dv. We want to pick a u that's fairly easy to differentiate, and then a dv that's fairly easy to integrate, right? So let's see it in action. And then there's a formula, right? So the formula for integration by parts is the integral of here, and I used to do it like this. The integral of u uv the action. These get a little bit nasty. Just you have to keep trying. Okay. Is choosing the correct u and dv. So we're gonna start. Let's see. Let u be 3x means would be e x dx. All right. So it's just from the original. So then the derivative of u, so our du there is going to be 3 dx. And the integral of dv, so the integral here, the integral of e is itself, but we got to say divided by 5. So then if we put these together, we're going to have, again, the original is going to be the integral of our u, which was this guy, times our dv, which was this guy. Formula, that's going to be equal to u, which is this, the integral of v du. So v is this. Trailing part, that 3 times that expression, we can move those terms to the front, and I think it's a simple integral at that point. All right, so let's keep going. So then this is going to be, we can kind of simplify it or rearrange it as 3/5 x e to the 5x minus, we can just pull that 3/5 in front of the integral like this. It's going to be the integral of e to the 5x dx. All right, I think that one we can just integrate as is. So the integral of e, everything comes down. E, this comes down. This is x, then we got to say divided by 5 plus some c. 3/5 x e to the 5x 3/25. Deep breath and like just keep trying, right? So let's start, and I'm gonna do my split view. To the following shows the correct formulation. Okay. So our UDV, we got 3/5 e to the 5x over 5 minus e to the 5 times 3dx. D looks good, so I'm going to go with that. After you evaluate the integral, we kind of saw it in action. Kind of miss my keyboard. And I think it's some setting or something that I gotta like lock the function key or something like that. Like X E to the let's just evaluate. Let's try another one, right? So we saw one, let's just do another integration by parts, right? Assume X is positive. So that means we don't need the absolute value. So that's why the other one we needed absolute value because we were not assuming that X was positive. So then, okay. The challenge here is choosing the correct U and DV. We might have to do integration by parts a couple of times. So let's just give it a go. We're gonna let U I think it's more simple. I'm gonna let U be the natural log of X, right? And then I'm gonna let my DV squared dx. Okay, so U, the derivative of natural log is dx over x. The integral of that dv over 3 is going to be the integral for dv for u dv u dv is going to be equal to u v. So u times v, that's going to be times x cubed over 3. Find the integration by parts formula minus the integral of v du. So then that's going to give us, go ahead and simplify those. Hopefully, I think that's okay. This x can turn that 3 into a 2. We're okay. So then if we keep going, 1/3 x cubed natural log of x squared is going to be what, x cubed over 3 cubed over 9. 3. Be 15 minutes. Let's just keep going. Just do the best you can, ask questions, just do the best you can. I think you can do it if you just keep trying. Evaluate using integration by parts or substitution. Substitution works. Hopefully that's not a trap. It might be a bait. Let's just go like this. Because it seems just glancing at it, it seems like I might be able to get away with substitution. You try substitution. If it doesn't work, then you go back and try integration by part. Evaluate using integration by parts or by substitution. So first I'm going to try substitution because it looks like we could say let u be x plus 5. That means our du take that substitution, the original is going to become the integral of ln u du. Is that u to the minus 1? So if ln is du by u, I feel like this might not work. I think I might be mixing something up. So instead of that substitution, um, four parts. If we say if we let u be the natural log of x plus 5, and our dv I don't think we can switch this around. Okay, so then our du in this case is dx over there. Our v is going to be x. Original, which was what the integral of u of x plus 5, which was just dx. Okay, see what happens. U times v, so it's going to be x plus 5 times our v, which is x, the integral of v to log. Should we do integration by parts again? P Will be x plus 5. I'm gonna be, let's see. Oh, choose the correct answer below to see what they're doing. Parts, that's fine. Mhm. From UDV, determine the choices for UDV that make it a little easier to solve. Integral because the antiderivative is not yet known, right? Because that's what we kind of ran into, the trouble we ran into. We tried to integrate the natural log, and I was like, we don't know that one. Q be natural log, that's fine. Initially, let's keep going. Du for this at one point. Let's keep going. Don't like that. What's there? I don't know how come. I see what they did different. Determine the values for dy. So then dy is just dx. Of y dv. Okay. Step in there and introducing that second step allow things to cancel. Like with hours, right? So I think they did both. They did like substitution with integration by parts. I don't think I've ever done that. But I mean you can do it, right? So let me kind of put a pin in this. Like this isn't wrong, but I think we weren't getting anywhere with that. So what they did, the part that was extra that I noticed, it said let y equal the x plus 5, right? 5, then that means dy is dx in this case, right? First, first let's make this substitution, right? I think they did substitution and then they did integration by parts, right? So if we substitute this in, it becomes the integral of the natural log of y. From there, I think they did integration by parts. So then that's supposed to be a dy, right? There, if we do, and let me label this as substitution, integration by parts. Mm. Let u be, okay, and then our dv dy, right? That's interesting. I don't think I've ever done it that way before, but that's okay. Let's keep going. So now if we just keep going, so then our du, the derivative of natural log is, let's back it up, is going to be dy by y. I can't even write my letters today. dy. Okay. On the right hand side, our v ends up being substitution in conjunction with this integration by parts. That's how they got the thing to cancel. Okay. So if we take this integral y dy, that's going to be uv. So that's going to be y natural log of y minus the integral of v du. So that's going to be y dy over y. But then these two guys cancel. Man, that's funky. Y equals natural log of y minus the integral of dy is like y plus some constant of integration. But then we need to go back and substitute y back in. All right. So then if we substitute y back in, we're going to get x of x plus 5. And simple plus 5. The natural log of 1. Uh, oh, I keep forgetting the plus c. There needs to be a plus c in there as well. Which one looks the closest? B. Negative. Oh no, my headphones. We're almost done. Sorry, I'm here. I don't know if you guys can hear me. Okay, it looked like it came back. I'm just gonna assume that you can hear me. If we distribute that negative, that's gonna be minus x minus 5 plus c. But minus 5 plus a constant is just a constant. So that minus 5 kind of gets absorbed by the c. Let me see. I'm thinking b might be okay. X plus 5, natural log of x plus 5 minus x plus some constant. Let's go with b. And we'll get this right. We're gonna do one more. Okay, and then we'll call it a day. Let me think about it. Which of the following? Okay. Yeah, it's kind of nasty. Let's give it a go. This will be it. Probably should stop while I'm ahead, but I want to try to do another one. We're gonna take it from here. And the strange thing is, like, I didn't have all these troubles with my older keyboard. It's just my older one just kind of broke. It's been old. I ain't gonna lie. I got mad playing the game. I threw it, and that started the end of it. That started the downfall of it. But I was like, it's okay. It still works, honestly. I just I didn't want missing keys. But anyway, okay. Let's try integration by parts here. I'm just trying to think. Again, the challenge is always like finding the proper u and dv. All right, so we're gonna start with let's let u be x plus 9. Okay. Let me think about it. Then the du is there. If we integrate that, I don't know, maybe we might need to do the substitution technique again like we did before. Like if we let y be x plus 9, I'm just trying to think if that helps us. If y is x plus 9, then dy is dx. That doesn't help us. Let me think. The du there is dx. dv could be, I don't think that works. Stop. Thank you. I'm not confident in this u. If we let that be our dv, can we integrate that? Okay, what if we did this? Let's see here. What if we said the u was the square root, right? And then that would allow our dv to be x dx, which we can integrate. So then if we go ahead and take this derivative, we're going to get what? 1/2. I think this might be making it worse. 1/2 x plus 9 to the negative 1/2. And then the integral that v is going to be, yeah, that's like x squared over 2. And that's not helping. Or is it? No, it's not. Okay. Can we switch those around? What if we let our u be x and our dv is that? Okay, let's try. Let's try and see what happens. Okay. So what if we let our u be x and our dv square root of x plus 9 dx, right? So then that means our du would be dx. And now can we integrate this guy? Our v looks like it should be what? X plus 9 to the power of 3/2 over 2 over 3/2. Let's just take a quick derivative to make sure it works. The power comes down. You subtract 1, then you got to say times 1, right? I think this works. Okay. So now, if that's proper, so then this original, which was this x root x plus 9 dx, that's going to be uv. So that's going to be x times x plus 9 to the power of 3/2 over 3/2. So that's u times v minus the integral of v du. So if you flip and multiply, you got 2/3 here, x plus 9 to the 3/2 dx. Okay. And I think we can integrate that guy. Let's keep going. I think we're on our way. So if you flip and multiply, you get 2/3 x times x plus 9 to the power of 3/2. I just kind of rewrote that. If you integrate there, you're going to get x plus 9 to the 5/2 over 5/2. You flip and multiply. You flip. So then we're going to get minus 1 over 15 times x plus 9 to the power of 5/2. I think this is okay, plus some c. Okay. So then if we could check this before we submit it by basically taking the derivative. We should get a whole bunch of things to cancel. I'm just not going to do it because we got to use the product rule for the first part. And then, I'm just going to submit this and see just for the sake of time. I think this might be okay. Not that one. Not that one. Okay. So let's give this a go. Oh, we have it here. Okay. Which of the following shows the correct UV minus the integral of V to U? Right there. So U times V, we got 2/3 X right there. Part C, I think C, right? 2/3 X times, nope. Where's the X? There it is. Let's try B. So 2/3 X times X plus 9 to the 3/2 minus the integral of 2/3 X plus 9 to the 3/2, right? Let's go with B. That's what we got. The match what we got on that line. And then the final result, it's a little bit, you know, 2/3 X, and then parentheses. And let me do the parentheses to the power. We got 3/2. Okay, let's get back here. X plus 9. Okay. Then we're going to say minus 1/15 parentheses X plus 9 parentheses to the power 5/2. Cross our fingers, plus a C. I mean, we probably can simplify. 2/3 X times X plus 9 to the 3/2 minus 1/15 X plus 9 to the 5/2 plus C. Okay. UV 2/3 X times X plus 9 V du 2/3 X plus 9 to the 3/2. That becomes 5/2 over 5/2. We flip and multiply 2. Oh, I see where the mistake is. So we divided by 5/2, right? So if you flip and multiply, you're multiplying by 2/5. So that needs to be 4/15 right here. Instead of that being a 1, that should be a 4. That's so nasty. And the only thing I messed up on was like some minor algebra. Minor isn't even like it's lesser. It's not lesser. It's just minute, right? Right here. It should have been a 4. Let's do it like this. Okay, so we got it now. Okay, so that because of stuff like this, so that's why I kind of set the class up the way I did. The unlimited attempts, you know, only a 10% late penalty because it can be like that. You know, some of these things. But we needed to talk about it, you know, because if you go anywhere else, you know, this is the kind of stuff they're gonna expect you to have been exposed to and have command over, right? And I felt like if we never talked about it or got to this point, I would be doing you a disservice. So we had to kind of keep that rhythm the way it was so that we got here. Now, I guess in hindsight, we could have slowed it down a little bit because we still got like a couple of extra weeks, maybe one extra week, right? So I think we're okay. But we got that one. Okay. I'm not sure if you guys are still there or not because I know there's some questions. I'm just trying to delay for a hot second to see if you guys have any questions. If there aren't any burning questions, then we're gonna end the session here. Let me see for next week. So again, our exam 2 is gonna open up next week. It's gonna be over chapters 3 and 4. And you can ask me questions about anything during class. You know, just do the best that you can. Like I know you're exhausted. I know I acknowledge the intensity of it, but that's what it is. So you just have to do the best you can, work together, use your tutors, ask me questions, just kind of get it done. Do your best. Okay. On that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day, guys. All right. Take care. See you.
Thank you. You too.
Mhm.
You too, Professor.